Alright, today we're going to be talking about central and inscribed angles of circles. Our objective is that we will be able to use angles, arcs, chords, tangents, and secants to investigate, verify, and apply properties of circles. We will be able to find arc and angle measures created by central and inscribed angles. So we've got some vocabulary to do. A central angle means the vertex of the angle is on the center of the circle. So it would be something like the angle APB. An arc is a piece of the outside of a circle. So we could have something like from A to B. That would be arc AB. A minor arc is an arc that is less than 180 degrees, so less than halfway. So arc AB is a minor arc, goes less than halfway around. Arc BC would also be a minor arc, that's less than halfway. The key thing about minor arcs are they are named with 2 letters typically. A major arc is an arc that's more than 180 degrees. So it would be something like arc ABC. Or it could be arc CAB. And major arcs must be named with 3 letters. Because if we just said AC, then that would be going straight from A to C. When we say arc ABC, we know we have to go from A to B to C. A semicircle is an arc that is exactly 180 degrees. So let's say we have a diameter through the middle. I'm going to make this point D. Arc AD would be a semicircle. It goes halfway. It's 180 degrees. All the arcs in a circle will always add up to 360 degrees. So for arc addition postulate, say we wanted to know the measure of arc ABC. But we don't know what that is. But if we know AB and we know BC, then those 2 arcs added together would give us the length of the whole arc. So let's look at some examples. Given that AB is a diameter of circle P, AD is congruent to BE. So I'm going to start by marking that on my picture. Arc AD is congruent to arc BE. Arc BF is congruent to arc DE. So BF and DE. The measure of arc DE equals 80 degrees. So now we're going to find out all these. But first, I want to label the picture. So we know that AB is a diameter. So from A to B is 180 degrees. If this part's 80, then that leaves us with 100 degrees for AD and BE. Well, we know they're the same, so I'm going to divide by 2, and now I know that those are each 50 degrees. Since DE and BF are congruent, I know that this piece is 80 degrees. And since A to B is a semicircle, if this piece is 80 degrees, then AF has to be 100 degrees. Now, one thing I'm going to point out here, even though the question doesn't ask us for it, is these angles inside, the central angles, or the measure of your central angles, is congruent, or is equal the measure of the arc. So if BE is 50 degrees, then angle BPE is also 50 degrees. If arc AF is 100 degrees, then angle APF is also 100 degrees. All right, now let's go back to our arcs. We're going to determine if it's major, minor, or a semicircle, and then we're going to find the measure. So BE, that's less than halfway, so it's a minor arc. It's also named with only 2 letters, and we said it's 50 degrees. FA, we said is 100 degrees. It's also a minor arc. AE, that's less than halfway, so it's a minor arc. A to E, well, we don't know that whole thing, but we know A to D and D to E. So 50 plus 80 means that it's 130 degrees. DFB. Now technically you can name a minor arc with 3 letters, so let's double check that this is a major arc. From D to F to B. Yep, that's definitely more than halfway. So from D to F to B, which has these 3 pieces in here. So 50 plus 100 plus 80 means that that arc is 230 degrees. From B to A to E. It's definitely more than halfway, so it's a major arc. Now, from B to A to E, we could add up all these pieces all the way around, but it's everything except this piece here. So a shorter way would say the whole circle is 360. Let's subtract 50 degrees, which means BAE is 310 degrees. Arc ADB, A to D to B. Well, that's exactly halfway, so it's a semicircle, which we know is automatically 180 degrees. Then FDB, definitely a major arc, and it's everything but this slice here, so 360 minus 80 means that's 280 degrees. So that's arcs and central angles. We're going to talk about some vocabulary before we move on to inscribed angles. So a chord is a segment that goes across a circle. Now, the difference between a chord and a diameter is a chord doesn't have to go through the middle. Let's put a picture. That doesn't cross through our center P. That's a chord. A secant is a segment that goes through the circle. It's going to start out here and go through the circle. That's a secant. A tangent is a segment that touches only one point on the circle. So like that. That's a tangent. So these three types of segments are going to help draw our new kind of angles, which are inscribed angles. The vertex is on the circle. So here's our vertex. The secant lines go through the circle to meet there. An inscribed angle is half the size of its arc. So the measure of angle LMN would be half the measure of arc LN. Like in an example here, x would equal half of this arc, and half of 126 means x has a measure of 63 degrees. Inscribed angles that intercept the same arc are congruent. So since angle ACB touches arc AB, and angle ADB, let me grab a different color, ADB also touches arc AB, angle ACB is congruent to angle ADB. So we have this angle that's 5x minus 2 intercepts this arc, and our angle 4x plus 9 also intercepts this arc, and 5x minus 2 equals 4x plus 9. To solve, subtract 4x, x minus 2 equals 9, add 2 to both sides, so x equals 11. For our last examples, I'm going to help you set them up, and then you're going to solve them before you come to class. So we have angle BAC as 5x. Arc BC is 9x plus 21. So we know that the angle is half of the arc it intercepts. For angle BAC this time, it's 20 degrees. If the arc is 20 and has to be half of what this was, in other words, the arc equals 2 times the angle, that tells us that arc BC is 40 degrees. What does x equal? And finally, we know that angle MNQ is 90 degrees. The angle equals half the arc. You solve and find what x equals. So before class, I want you to solve and find what x equals for 8, 9, and 10. See you.